Hi guys, for today's video we're going to be dealing with differentiation using the product rule. So what do I mean by the product rule? It's a technique used to differentiate functions where two functions in terms of x are multiplying. So that probably doesn't make much sense, but you're dealing with this sort of situation down here. Have a look at this function. So y is equal to 5x squared. That's kind of a function with x in it, 5x squared. And then it's multiplying by another function, which is the square root of x cubed plus 1. These can't simplify to make kind of one function together. They're definitely two things that are just multiplying, and you just have to kind of shove them next to each other, and that's as simple as it gets. So when we want to differentiate this sort of thing, we want to use the product rule because these two things are definitely multiplying each other. So these are the formulas for the product rule. You need to follow these formulas to figure out our dy dx, which is what we're trying to figure out. Find dy dx, which is the derivative of y in terms of these x's. Now, with these formulas, you're dealing with u's and v's. We need to know what u and v is. So u is the first function of x. So if you look here, u is going to be this first one here, this 5x squared, which is multiplying. And then the next one is v, the second function of x. So v is going to be the second one, the square root of x cubed plus 1. And when we follow this formula, we've got u multiplying by the derivative of v, and then plus v multiplied by the derivative of u. So it's just about finding these four things, 1, 2, 3, 4, and then just plugging them into this formula and then simplifying where you can. So let's give it a shot. Okay, so first up, we let u equal this part. So u is equal to 5x squared. That's the first part. That's 1 out of 4 done for our formula up here. Next is v. V is equal to the square root of x cubed plus 1. So that's the second one done. We've done 2 out of 4 so far. Now we need to find the derivatives of both of these things. So du dx is going to be the derivative of this, which is going to be 10x. So that's the third one done. We've done 3 out of 4 so far. Differentiating this one to get dv dx, that's going to be the hardest one to do. So we've got to take the derivative of this thing here. We want to get rid of that square root sign because that's hard to differentiate. So change it to x cubed plus 1 to the power of half. When we differentiate this, we've got to move this power to the front of our bracket, and that power goes down by 1 to negative half. Our bracket's going to stay the same, and we've got to remember to multiply, because of the chain rule, by the derivative of this bracket. So the derivative of this bracket is going to be 3x squared, so that is multiplying by all this stuff. That simplifies by this part here, multiplying by the top of this fraction here. So it's going to be 3x squared over 2. And that bracket's going to stay there. We want to get rid of this negative power of a half. So that bracket's going to go down to your bottom. To the power of half means the square root of it. And remember, this 2 is on the bottom as well. So that 2 is going to be down there with the square root part. And the 3x squared is going to be on top. So we've got our u, our v, our u dash, and our v dash. 4 parts are there. So I prefer to use this terminology here. The v dashes are a little bit easier to write rather than dv dx, but these two things are technically the same. Okay, step 2. Now we jump to the formula and we change our 4 things to what we found them to be. So we've got u is the same as 5x squared. V dash is this nasty looking thing. V is this part here. And u dash is our 10x. And now looking at this thing, we think, how can we simplify it? Well, looking at these two things that are multiplying, our 5x squared can multiply by the numerator. So that gets 15x to the power of 4. The denominator just stays the same. We don't want to simplify that sort of thing. 10x times a third, the 10x just jumps straight to the front. And we get 10x multiplied by x cubed plus 1. This is going to be our final answer for our derivative. Let's try another one. Let y equal this function here. We've got 2 parts which are multiplying, and they're both in terms of x. So this is the situation where you'd want to use the product rule because you can't really simplify this any further without expanding these awful brackets. Okay, so first up, let's find dy dx, the derivative of y in terms of these x's. Step 1, let u equal this first part and let v equal this second part. So we've got 2 out of our 4 parts for our formula. Next up, differentiate u, which gets the derivative of this is 8x. So that's our third part done. And lastly, let's differentiate this using the chain rule. So our 3 comes to the front. Our bracket stays the same. This power of 3 becomes a 2. And we got to multiply by the derivative of this bracket, which is going to be just times by 2. 2 times the 3 gives us our 6 out the front of our bracket, 2x plus 1 all squared. So there's our 4 parts that we plug into our formula. So let's do that now. So we get this big line when we plug it all in. And we can simplify this first part. The 4x squared times the 6 gives us 24x squared. And this bracket here, 2x plus 1 all squared, that just stays there on the end. This part here, our 8x is going to just jump to the front. And our bracket, we don't want to expand. We can just leave it like that. So that is our dy dx. The next question is wanting you to convert this dy dx to factored form. So the reason this is not factored form, even though it does have brackets in it, is because we want everything in this to be multiplying. Factored form is when you change a number to its factors, the numbers that multiply together to give it. Because we've got this plus in the middle of these two terms, this is not in factored form. So we need to be able to try and factorize this sort of expression. This can be really helpful to solve problems when we're using these derivatives. So this is our derivative, which I've just pulled from here. We want to try and factorize it. I want you to see that there's 2 terms which are split up by this plus in the middle. And we've got to think what is common between these 2 terms. So just like normal factorization, when you're factorizing 2 terms, the highest common factor of the terms is taken outside a pair of new brackets. So if we look at our 2 terms here, these 2 up the top, we can kind of look at them and think, okay, what's going to fit into both of these terms? I look at the 24 and the 8, and I think 8 is definitely got to fit into it. I'll change this color. So 8 is going to fit into both of these, looking at 24 and 8. If I look at x squared and x, x can fit into those 2 parts. And if I look at these brackets, I think to myself, well, there's 2 brackets of 2x plus 1, and there's 3 brackets. So 2 of these brackets, so like 2x plus 1 squared, can fit into both of these terms. So that means that 2x plus 1 all squared is going to be part of my highest common factor. Okay, so our factored form is going to be looking like this highest common factor out the front of a new set of brackets. So this is going to be what our factored form is going to look like, something like this, but we still need to find these 2 parts. Okay, step 2, we need to divide both original terms. So the original terms are these 2 right here, by the highest common factor. Divide those by the HCF to determine the terms that are inside these brackets, these question marks. So we'll take our original terms and we're going to divide them both by the highest common factor. So there's going to be a lot of cancelling that happens here. You've got your 2x plus 1 squared and your 2x plus 1 squared. They're the same. They're going to cancel out, as you can see here. X squared over x. One of these x's is going to cancel out, and that x is going to cancel out, leaving you with just 1 on top. And the 24 over 8, that's going to cancel to a 3 on top. That just becomes 3x. That's going to be your first part of your brackets. Next up over here, we've got 2x plus 1 cubed over 2x plus 1 squared. 2 of these brackets is going to get rid of 2 of these brackets. So there's just going to be 1 left over up the top. The 8 over 8 cancels and the x over x cancels. So this leaves you just 1 bracket of 2x plus 1. So that's the first question mark. That's the second question mark of our bracket. So therefore our factored form becomes this. And lastly, we want to simplify where possible. And this bracket here can definitely simplify. We've got 3x and 2x. They're like terms. They become 5x. And the plus 1 is unlike, so it's just going to be 5x plus 1, and all this stuff just comes down. This is factored form. You can see that this this and this are all just multiplying together. So therefore, that's what factored form means, just things that are multiplying. Question C, for what values of x does our derivative equal 0? When is our gradient equal to 0? Or when is our function flat? Because that's what a gradient of 0 is. So the idea is we want to let this factored form equal 0. And then we solve this equation. Because it's in factored form, it's really easy to solve for 0. We let each of these factors, the parts that are multiplying, equal 0. And then you solve for x. So for example, 8x equals 0. 2x plus 1 squared equals 0, and 5x plus 1 equals 0. These are nice, easy equations. We get that x is equal to 0, x is equal to minus a half, and x is equal to minus 1/5. So at these values of x equals 0, minus a half, and minus 1/5, the gradient is 0 for this original function. So if we graphed this, we would know that the gradient would be flat at these values of x. Hope this helps with the questions. Good luck.